Okay, so title and notes, proving trig identities. And I'm going to start with our first example and kind of teach you what we're needed to do as we work through these examples, okay? So example 1, we want to prove that the secant of x minus the tangent of x times the sine of x is equal to 1 over the secant of x. Okay? So we want to prove that there's equality. Now, when these are given to you, there's no doubt that there is equality. Someone's already proven it. They know that this is an identity. They just want you to see that this is an identity. Okay. The rule of this game is different than the rules of solving. Like, for example, when you solve equations, you can change the value of each side of that equation. For example, if I have 2x equals 6, and I want to solve that, you guys learned, well, we can divide both sides by the same number, and equality holds, and we get like x equals 3. They're still equal to each other. But in doing that, we've changed the value of the right side and the left side. It went from 6 to 3. So here we can't do that. We can't add something to both sides or subtract something from both sides or divide or multiply or anything like that. You have to kind of stay on your own side. And if it helps, you can draw kind of a wall here to remind yourself, I can't intermix sides. So I'm going to work with, I pick a side to work on. You can work on the right side or the left side. Typically, you start with the more complex side. Which side looks more complex to you? Probably left side, because there's more stuff there, right? And so you work on that left side and try to make it look like the right side. So secant, well, one of our techniques that we learned is to change everything to sine and cosine. I'm going to do that. So secant is 1 over cosine x. Tangent is sine x over cosine x. And sine is already in the form we want, but I'm going to write it as a fraction, sine of x over 1. Okay. And we're wanting to create 1 over secant of x. Well, I could multiply out the right side of this, and I get 1 over cosine of x minus sine squared of x over cosine of x. And remember the rules of fractions. We can subtract fractions if the denominator matches, right? So here we have the same denominator, so we could subtract 1 minus sine squared of x all over cosine of x. We could pause and say, okay, does that look like the right side? Not yet. We have one fraction on the left, one fraction on the right. Is there anything you see we can do? Okay, we can use a Pythagorean identity on 1 minus sine squared x. Okay, 1 minus sine squared x is the same thing as cosine squared x over cosine x. And we can reduce that. Cosine squared x over cosine is just cosine of x. So now the left side is cosine x, the right side is 1 over secant x. You see how to go from one to the other? Yeah, cosine of x is equal to 1 over secant x. That's from the reciprocal identity. Okay, so now we made one side look like the other. That's what a trigonometric proof looks like. Okay, so it's not a geometric proof where you have to quote different theorems and stuff like that, but you're just algebraically showing that one side is equal to the other. Okay. Okay, second example. Want you to prove 1 plus cosine x over sine x is equal to cosecant x plus cotangent x. Okay. We want to prove that one side's equal to the other. You get to pick which side you want to work on. You can work on the left side first or on the right side first. Both are about the same difficulty. Both work. Let's vote. Which one you want to go for, left side or right side? Who says left side? Who says right side? Okay, right side wins. So right side, we can change the cosecant to 1 over sine. We can change the cotangent to what over what? Cosine over sine. We got two fractions, both have the same denominator. We can add them, and we end up with 1 plus cosine x over sine x, and we're done. The left side matches the right side. Okay. Anybody want to see how the left side would work if you did that left side first? Okay, if you start on the left side, you would notice, okay, I have one term or one fraction on the left side, but I got two pieces on the right side, so you need to split that up. I'd split it up to 1 over sine plus cosine over sine. 1 over sine is the cosecant. Cosine over sine is the cotangent. And we got it. So either side would work on this one. Both are the same difficulty. Okay. All right. Example 3. Prove secant theta times sine theta divided by tangent theta plus cotangent theta prove that that is equal to sine squared theta. So which side looks more complicated? Which side would you start with? Left side, right? Left side's a lot more complicated than the right side. It's always easier to make something more complicated less complicated than it is to make something simple like sine squared look like the left side. Okay. So we're going to start with the left side. How do we start? Any ideas? Okay, secant times sine, how do you do that? Put everything in terms of sine and cosine. You could always fall back on that, okay? So secant, we know is 1 over cosine. Sine, just leave it sine over 1 maybe. And that's just the top part of the fraction, right? And tangent, sine over cosine. Cotangent, cosine over sine. So that's what it looks like to change everything from, any basic trig function to putting things in terms of only sine and cosine. And then that numerator, the 1 over cosine times sine over 1, we can change to sine over cosine. Just multiply those fractions together. But how about that denominator? Can we just add those together as is? Do we need to change that? When you add fractions, you need a common denominator, right? So what what should our common denominator be? Or what that first fraction, what do we need to multiply the top and bottom part of that fraction by? Sine theta. The second fraction by cosine theta. So when we do that, we end up with sine squared theta over sine theta times the cosine theta, plus second fraction is cosine squared theta over sine theta cosine theta. And you may be thinking, this looks even more complicated than it started, and it kind of does look that way, but it's going to get better now, okay? Because now we have two fractions that have the same denominator in the bottom of a bigger fraction, right? And we can add those together and get sine of theta over cosine theta. Numerator stays the same. Over sine squared theta plus cosine squared theta all over sine theta cosine theta. We're making progress. Anybody see what can happen next? Okay, sine squared plus cosine squared is 1. Definitely want to replace that with a 1. Okay, and then we have a fraction divided by a fraction. So we're gonna take the top fraction and multiply it by the reciprocal of the denominator. So we end up with sine theta over cosine theta times the reciprocal, which would be sine theta cosine theta over 1, right? Instead of sine squared plus cosine squared, we're going to make that 1. So you don't lose it. This piece right here became that piece right there. Okay, so now we can reduce this fraction, divide top and bottom by cosine, and we're left with sine times sine, which is sine squared theta. And now if I back that up, you see the left side equals the right side. Okay, so some of these are longer than others. Some are you can prove in 2 steps. Some you got to take more than 2 steps to get there. Questions? No. That was example 3. Example 4. Prove secant theta over cosine theta minus tangent theta over cotangent theta is equal to 1. Okay, let me give you a little time to try this. See if you can get to it. So secant is 1 over cosine. Cosine, you want to make that a fraction, that's cosine over 1, right? Tangent, sine over cosine. Cotangent, cosine over sine. So this is what it looks like when we change everything in terms of sine and cosine. When you have a fraction divided by a fraction, you take the first fraction, the numerator, and multiply it by the reciprocal. Flip the denominator over. We get 1 over cosine theta times 1 over cosine theta minus sine theta over cosine theta times sine theta over cosine theta. That's what it looks like. You change the division problem into a multiplication problem. So we end up with 1 over cosine squared theta minus sine squared theta over cosine squared theta. Now we need to subtract the 2 fractions, make it 1 fraction. Denominators match already. So 1 minus sine squared theta over cosine squared theta is our one fraction. So now we can compare, what were we trying to find? Oh, we're trying to show that that's 1. Okay, we're not there yet, but we've now gone from 2 fractions to 1 fraction. Once you get that far, you're almost done. Anybody notice what can happen from that point on? Okay, there's a Pythagorean identity. 1 minus sine squared is the same thing as cosine squared. And cosine squared divided by cosine squared is 1. And we made it. Okay? Yes. Okay, how'd you do it? Did you start the same way? Well, how'd you start? Okay. Nice. Okay, here's what he did. So he changed that first fraction. He saw that that's the same thing as secant times 1 over cosine. Right? If you multiply those together, you get secant over cosine. Second one is tangent times 1 over cotangent. 1 over cosine is secant. So this is secant times secant, or secant squared. 1 over cotangent is tangent, so this is tangent times tangent, tangent squared. And then if you go to Pythagorean identities, that's equal to 1. So that was kind of you're able to do it without fractions in that case, right? So there's often creative ways you can come up with that will work. Okay, next example, 5. Okay, we want to show that the cosine squared of y minus the sine squared of y is equal to 1 minus 2 times the sine squared of y. Now in this one, our technique of putting everything in terms of sine and cosine is not going to help us because everything is already in terms of sine and cosine, right? So we only have 2 techniques. That's our first one. Our second one is Pythagorean identities. And so we're going to have to use a Pythagorean identity to help us out here. There's 3 Pythagorean identities, but there's only one that deals with sine. So you have to use that one to help you. Okay, so try it out. See if you can show that one side is equal to the other. You should be able to do this in 2 steps. So first pick a side. Right side? Okay. You pick the right side. What you're going to do is look at the right side and what does the left side have that the right side doesn't have? Cosine, right? Cosine squared. And so somehow we're going to have to create a cosine squared. Okay, so somehow we're going to have to create a cosine squared on the right-hand side. Well, what's 1 equal to? Sine squared plus cosine squared. I'm using theta, it should be y, huh? So I'm going to change that 1 into sine squared plus cosine squared. And I still got the minus 2 times sine squared y. Okay? Now I got a sine squared 1, there's a 1 in front of this one. I got 1 sine squared y on the left side minus 2 sine squared y. What's 1 minus 2? Negative 1. So that cosine squared is still there. And 1 minus 2 is negative 1 sine squared y. And now the right side looks like the left side. Okay. Did anybody start on the left side? If we start on the left side, and you wanted to make it equal to the right side, you'd still ask the same question. What is the... Notice that the right side didn't have a cosine, right? So you'd have to change this cosine y into something that it's equal to using a Pythagorean identity. What would you change it to? 1 minus sine squared y. Still got that minus sine squared y over here. And I got 2 negative sine squared y, so this is 1 minus 2 sine squared y. So that's another way to do that. Whichever one you like better. Okay? So you pick the side.